Hello, Santosh Kumar this side. So I'm back with my first video as promised. So in this session, we will see previous year gate questions. Before going to previous year gate questions, today we would like to see the concept on which the next video will come, having the problems which have been asked on this topic from the previous year gate papers. So today's session topic is let me choose the pane. Yeah, so today's session topic is no load transformer, or in better way we can say transformer at no load. This session will consist of concepts, basic concepts about transformer at no load. Second unit point is formulas on which questions has been asked as problem solving technique. Now this is a short video. It will consist of 15 to 20 minutes lecture delivery, particular to the transformer at node. Now we will come to our lecture. Now see, this is our transformer. Now this video is useful to only those students who have gone through the topic, not for the undergraduate students who are studying the courses, but for those students who have preparing for certain competitive examinations like GATE or PSUs, and they have covered the topic. But I'm not going into the detailed analysis, but only those things will be covered which are useful for your upcoming GATE preparations or any competition examination, and also for the assistant professor recruitment through BPSC, which is going to be held in most probably in October, November, December of this year. See, this is the transformer. Now, transformer basically consists of, in our machine language, two parts. One is iron and other is copper. At no load, only iron. That is 4. Now see why I am stressing, giving stress to this. Line we will see. Now this is the transformer. Core is there. This is the core. Either you say core or you say iron. Now let me draw the copper also. That is the winding. Copper means winding. Iron means core. Now what will happen at no load? We all know the functioning working of the transformer. So main concern is that at no load, at no load, voltage induced E1 on the primary side or E2 on the secondary side. So voltage induced is equals to RMS value of it is equals to root 2 pi F 5 max N1 for the primary side and root 2 pi F 5 max N2 for the secondary side. So each and everything is clear. So we have to remember this. We have to remember this. We will see how the question is solved. This formula next video, but now phi dot is the maximum flux in the core. Second important thing at no load is the primary current that is flowing through the transformer. Now at no load, I1 is equals to I no, which is there was a technical glitch, it has been sorted out. So only magnetizing component of primary current flows at no load conditions. So how we can find the magnetizing current or no load current? So formula is which will be useful in calculating the I no load. The formula that is useful is MMF is equals to flux into reluctance of the core. So we can say MMF, we can say number of turns primary I no load is equals to flux in the core into reluctance of the core. So from here we can derive that second formula. This is useful for finding no load current is plus reluctance upon number of turns of the primary. So this is the second formula which we have to memorize or we have to be understand. So this is the second during no load conditions. Third, we know from the magnetic circuit, if you visualize the magnetic circuit, reluctance that we don't have to remember, just like resistance, if we treat reluctance as resistance, is nothing but 1 upon mu length of the core upon area of cross section of the core. So this is the third formula which we have to memorize. These are formulas will be useful in our next video when we are going to solve the previous year GATE questions based on the topic. So these are the questions that are useful. Again, one more important concept at no load is power at no load. Power at no. So power at no load is nothing but it is power at no load is nothing. It is equals to the core loss or iron loss, which is proportional to the volume of the core. Volume of the core. So power at no load is proportional to volume of the core. This is the fourth statement or fourth concept that we have to memorize or we have to understand. So these four basic concepts we will keep in our mind the next session, which will be based on the questions that has been asked on this topic in previous year papers. Will find it useful solving those problems based on the four concepts that has been discussed there. First one is about the voltages induced at no load conditions. Second one is the no load current. Third one is the reluctance. Fourth one is the no load power or the iron loss. With this today's session, I'm signing out, but required your lots of love from your side because this initiative is free of cost, no monetary gains. So only thing that is required from your side is lots of love, comments, subscription, so that I'll be gaining the motivation. I will be having the motivation to produce and to publish more and more videos of this kind, making electrical machine easier and simpler. So with this, bye. See you in the next videos very soon. You will enjoy